.NET 6 IoT with Bryan Costanich.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. They are hiring both architects and .NET engineers who'd like a path to become an architect. So you can go to clearmeasure.com/careers for that. And also be sure to check out the new video show, Architect Tips. Now, our guest on the show today is Bryan Costanich. He is the founder of Wilderness Labs. He's also a former vice president of Xamarin, and he's trying to leave the world a little better than he found it. Bryan, welcome to the show. How are you, sir?
Fantastic. Thanks for having me, Jeff.
Oh, my pleasure. My pleasure. You've done quite a few public speaking engagements out there, but we never had you on the show. But before we get into the topic at hand, for those who maybe haven't seen you speak or haven't looked at some of the Wilderness Labs stuff, give us a quick rundown. What's your background? What are the key things that kind of led you into the position you're in today?
Yeah, sure. So as you mentioned, I was a VP over at Wilderness Lab. I'm sorry, at Xamarin, and I built out the education services team. So I built out the docs team, and then built and created Xamarin University, and helped out on a lot of different fronts over at Xamarin. I was first leadership hire over there, came on about a month after it formed, and it was a heck of a ride. It was a lot of fun, made a lot of friends. And now, I'm back at it. I'm doing something very similar. At Xamarin, we brought the .NET ecosystem to mobile, and at Wilderness Labs, we're bringing that ecosystem to IoT and embedded development, hardware, because it's a real struggle today if you want to build hardware. And, we set out with a mission to make building hardware as fast and easy as mobile development, web or mobile development. And so that's where, we're chipping away at that rock.
Shoot, that's a huge story, just coming from Xamarin, but then pulled into Microsoft, but then quickly came out of Microsoft because now Maui is like fully integrating everything that Mono Project and Xamarin did kind of in the .NET 6. But
cool to see it live on, and
totally
and become, sort of be next. Right.
Everybody's excited for that coming out later this year. But with the state of IoT, I mean, I've followed. I've got your Meadow board. I've got several Raspberry Pis, Arduino, Panda, just all these other things, and thinking, okay, we've been told that I can write C# and have it run on a system on a chip, or all these little boards.
Yeah,
but so many .NET developers find it really hard to actually accomplish that. What's the state of .NET in the embedded system on a chip world? What are the realistic options right here in 2022?
Yeah, that's a good question. It's it's funny because some of the messaging on this is a little bit muddled, especially by Microsoft and some of the other players out there, and there's also unpacking that there's sort of like different levels of compute that we should consider, right? Because the first thing is to understand like the difference between an embedded microcontroller or an embedded device and like a Raspberry Pi, right? And those are different levels of compute. A Raspberry Pi is a single board computer, and it's basically like a computer from the early 2000s that they shrunk down and made very tiny and added some hardware IO, right? And that's super interesting, right? That sort of like kicked off a lot of development in IoT. It gave people like a way to use modern development tooling and frameworks and control IoT. The challenge there with that, that sort of computing level is that one, they're not, the hardware sort of came as an afterthought, right? And there's just not a lot of great hardware on a Raspberry Pi. So there's like, typically you get, one or two PWMs, which is a type of signal that you can generate that drives a lot of things like servos and motors and things like that. And there's like, usually one analog input. That's, for reading analog sensors and things like that. And, but you have all this, you have this sort of like modern development environments. You can, fire up Visual Studio and you can write sort of up level applications and run it on there. And for the most part, it's like writing a Windows app or something. And then there's the next, computing form factor down. And that is the embedded space. And the embedded space is really, when we talk about that, we talk about microcontrollers. And microcontrollers, there are trillions of them in the world. And, last year there was something like 12 billion made and shipped. And microcontrollers are interesting because they really are a different class of computing. And the first thing, that's sort of like the litmus test is this a microcontroller, or is this a single board computer, or is this embedded Linux versus embedded, true embedded is does it run a full operating system, right? And if you look at microcontrollers, they run typically micro real-time operating systems, and they are, just enough OS code to service a single application and provide, a hardware abstraction layer so that you can access the hardware. And that's a pretty big distinction between like embedded Linux running on a single board computer, where you can have multiple applications, you've got multiple users, and the OS is the heaviest thing. In the embedded space, it's just the opposite. The app is the thing, and the OS is just enough there to provide the services that you need. And there's a number of advantages there to moving down into that embedded space. There's a number of disadvantages as well, but the advantages is that when you move down into embedded, it's what's known as low swap C. So that's low size, weight, and power, and now cost, which is the C. That's kind of a new term tacked onto there. And oftentimes these embedded devices will use 1,000 of the power of like a Raspberry Pi, right? So you can run these on very small batteries, where like a Raspberry Pi, to have any meaningful battery life, you need a laptop battery, right? Because it really is kind of, you think of it almost like a laptop. And the other thing about the embedded devices is that they really were designed for hardware control as a first class design consideration. And so you look at like our F7 Meadow F7 board, and it's our dev board, and it's got like 6 analog inputs, and it's got 12 or 13 PWM outputs, and so it's really, a different from the perspective of hardware. It was really designed for that first, and so it can drive that hardware in a much more sophisticated way. It has a lot more IO and things like that, right? The other thing about embedded is that they tend to be, microcontrollers and boards that are built around microcontrollers tend to be much smaller, and they also tend to be cheaper to embed, right? So like microcontroller solutions like ours, for example, like at scale, you can go to market at $30 on one of these boards, and eventually we're going to release a budget board that will be even, much cheaper, maybe somewhere around half of that at scale. And if you compare that to something like a Raspberry Pi, when you actually go to scale, it costs you $50 or more to embed that. Yeah. And that's because, those are little computers and they require a lot more components, and they require, their bill of materials is much more sophisticated and to drive all those components, whereas microcontroller is like a computer all in one. And that's even with scale, right? So Raspberry Pi moves a ton of units, and even with that scale, it speaks to the fact that ultimately is just a much more complicated piece of hardware, right? Now, so that's sort of the advantages of a microcontroller moving to embedded, but there's also a number of disadvantages. And a lot of these are historical in the sense that, like, developing for embedded devices hasn't really changed a lot since the 70s and 80s. Like most, I would say 95% plus of all professional production IoT that's built on embedded, and most IoT is built on embedded anyway, is built in embedded C. And embedded C is a really, it's a challenging thing to develop in. It takes a very specialized skill set, and there's just a small fraction of developers in the world that can actually write embedded C. And then you struggle a lot with, like, things that we don't even have to think about as a .NET developer, from the tooling, the build chain to, like, fighting with CMake files and make files and trying to match your OS with these, with like these drivers and that library and blah, blah, blah. And then also, memory bugs and managing memory. Like, in C, you have to think about memory, whereas with .NET and other managed runtimes, you don't, right? And I saw this interesting statistic that Google put out, which is that 70% of all security bugs are actually memory bugs, right? So that's like 70% of all security bugs aren't even an issue in .NET. So, so historically, building for embedded devices has been really challenging because you had to have the super specialized skill set and do embedded C. And then, there's been some interesting developments here in this front to make this easier, right? 20 years ago, the .NET Micro Framework came out, and that was like a v1.0 .NET attempt by Microsoft to get into this embedded space. And it was actually a pretty forward-thinking platform, but it was always very limited, and it never really got any updates after .NET 1.0. So for example, generics never came to platform, right? You were, instead of having list of type T, it's array list, and you don't get to use any of the modern NuGet packages, et cetera, right? And that's what you see in, like, solutions like the Nano Framework, which is a rewrite of the .NET Micro Framework, right? It's still 20-year-old tech, and you don't really get full .NET. And so there's in other spaces of the market, two things have been interesting, or things have been happening that have been interesting. For example, MicroPython or CircuitPython, right? And CircuitPython and MicroPython is really interesting. It really made IoT development, or embedded IoT development, a lot simpler, but also, sort of suffers from the fact that it's a very slow, interpreted platform, and it's not full Python. It's really a subset. It's almost like the Micro Framework or Nano Framework, right? In that it's a subset of the experience, but still very interesting. And so, we were looking at this after we got acquired by Microsoft. I was sitting over there, and I'm not really a big box company. I need to be able to, like, make changes and move fast and stuff. And so
after Xamarin got acquired, right?
Yeah, that's right. Yeah, when Microsoft bought us out, and it's tough to get anything done over there because it is a big company, and that's just the nature of the business. Is big companies, they got a lot more things to worry about when you're building stuff. And so I always loved hardware and always been playing in that space, and I got to thinking, how do we make this easier for folks? Like, what would be the ideal experience? And for me, that meant like full modern .NET on embedded devices. And at Xamarin, we did a lot of really good work to sort of lay the groundwork for that, right? We first of all, we got .NET running on exotic platforms, not just Linux, but on ARM, right? And we got it on iOS and Android and Mac, and that was a whole different, CPU architecture. And then there was a lot of work, a lot of really interesting and important work done around IoT, ahead of time compilation, and of course linking, which would strip out unused code, also known as tree shaking, and make your assemblies much smaller and save RAM and increase boot up speed and stuff. And so because of the work that we did at Xamarin, all of a sudden I was looking at this and I was like, the next phase of humankind's technological computing journey is embedded computing, right? The idea, like in my lifetime, we've gone from desktop computing, big desktop apps, and the web hit, and everyone was building on web, and JavaScript was, changed the world. And then the web turned to cloud, and everything shrunk down into mobile, and now there's interesting things happening that are sort of tangential to all that. It's AR and VR and AI and stuff, but like the biggest single market in tech right now that's non-financial market is embedded computing, because this is in fact the new revolution. And it's an interesting one because unlike with mobile, there's no hero experience, right? Like 15 years ago, Steve Jobs got up on stage and we saw this beautiful piece of cinematic glass, and all of a sudden our lives were changed, right? We got it. And then Google Maps, think about your life before and after Google Maps. I mean, it's night and day, right? And now that's happening with embedded devices, but it's a quiet revolution because we don't, there's sort of three phases. There's three parts of the IoT market. There's consumer IoT, commercial, and industrial. And commercial and industrial make up about 90% of what's happening. And we don't really see that in our day-to-day because what we think of IoT is like consumer IoT. We think about smart toasters and smart fridges and stuff. And so there's this massive revolution going on. And we're seeing this we're seeing the outcome of this in like supply chain, how people can't get chips. And, we blame it on COVID and whatnot. And to some extent that is true, but also pre-COVID, chip, microcontroller demand was like going through the roof because everyone's building all this IoT in industrial and commercial sectors, right? So I was looking at this, I was like, okay, how do we fix this? How do we fix this like broken place? Because I'm a .NET developer, I want to do hardware.
Yeah. And
so the first thing was like, okay, we need to take the next step with what we did at Xamarin and Mono. We need to get that running on a microcontroller, right? And then we started to do that. And we got Mono up and running, and that was like first step. And then the next step was, okay, we've got all these devices out there, all these peripherals, there's sensors and there's displays and there's, servos and motors and GPS receivers and stuff. Now I want to make that so easy to integrate. I just want to give everyone like APIs for those. So then we created this Meadow Foundation, which is this massive, library of drivers, peripheral drivers, and industrial control algorithms, et cetera, to make all that easy. So that was kind of the thrust of like what we set out to do is make a platform in which regular .NET developers like you or I could pick up a piece of hardware, could plug some stuff in that we got from SparkFun or Adafruit, and we could actually make sophisticated embedded IoT applications that can go to production, that we can put into the market, just like, Xamarin had a number of the top apps in the App Store, with Meadow, you can go to production, you can build products that you ship to, thousands, hundreds of thousands of units, and then be able to manage them out in the field. That was the other piece that we've been working on is being able to like do over-the-air updates and send security patches out to your devices and do automatic crash reporting. The way that we used to have in Xamarin, where like your app would crash and you would automatically upload it, and you could see what the error was and stuff. And so that's, that was kind of like, that's the thrust of why and what we've been building.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast,
delivering quality and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
You mentioned the spectrum of types of devices. Just help us understand the Meadow product line, because I think a lot of people who go to the Microsoft conferences are going to hear about Azure Sphere. They're going to hear about the Raspberry Pi. And you mentioned Raspberry Pi, but Azure Sphere, that's embedded C. You gotta write a little bit of C, and then it's hardwired just to go straight to Azure. Talk about your main products. How are they comprised, and where on that spectrum do they land?
Yeah. So again, unpacking that a little bit. Yeah, Azure Sphere is an embedded that's an interesting product because it's almost an embedded device. It's so strange that Azure Sphere, their product line, because what they did is they took like an app processor that you would find in a mobile device, but then they paired it with sort of more embedded levels of RAM and flash. So it's a really kind of a strange thing. But the one thing that they did on Azure that I think was smart is that they had a good security story around being able to encrypt your application and prevent side loading, right? And we did the same thing with Meadow, and so Meadow is a true embedded device, a true microcontroller platform. And we actually, on our current line of boards, is the Meadow F7, what we call the dev board, and then our core compute module. And the dev board is a little bit of a misnomer because you can actually, it has development features, but you can actually go to production with that. And a number of folks are actually building production IoT on that board. And then if you need like the absolute minimum to run Meadow apps, then we have this core compute module. And that's really designed for folks that are building products that will go out to, quantities of 10,000, 100,000 or more devices out in the world. And as I said, it's a true embedded architecture. It runs an STM32F7 microcontroller. That's the main brain on that.
And you're going to have to tell us what that is.
Yeah. So that is, if you look around and you look at a lot of the boards out there, they are something, a lot of like the Arduinos and Particles of the world, et cetera. Those are very similar devices, embedded devices. A lot of those are actually STM32F4s or equivalent. This STM32F7 is very similar. It's about twice as powerful as the F4 chip, but uses half the energy. It's a nice low energy device. And it is, again, it's a true microcontroller, runs in micro RTOS. You're not going to run Windows or embedded Linux on it. And it draws very little power, right? This is a device that you can run on just a small battery for a long time. And we've coupled that with an ESP32 coprocessor. And what that does is that adds Bluetooth and Wi-Fi to the mix. And then we've added 64 megs of flash and 32 megabytes of RAM. So we basically gave you plenty of room to build like really sophisticated applications for IoT, so you can drive displays and you can put a web server on there and you can have a Bluetooth server and you can have all your hardware IO and you can also, with that 64 megs of flash, that means you basically have a hard drive on there to store your logging and, you can run a database. We have we have a SQLite on there. So you can run the same SQLite code that you do on mobile, you can run it on there. And so just about anything that you want to build in terms of IoT, you can power with that board.
Now, looking at the F7 looks kind of like a stick of gum, and then the core compute is I don't know, how big is that? That's a little bit bigger than your 2 times the size of your thumb, but it's flat, totally flat. What's the IO like that? Is it meant to be kind of solder embedded into other circuit boards?
Yeah, that's right. So, the Meadow F7 dev module you can put headers on there and you just plug it into like a breadboard, or you can solder it. It's also surface mount compatible. So you can solder it down into your own circuit board that has sensors and stuff built in. And the core compute module, which is about the size of a quarter, that is meant to be a true embedded on it's got very, little tiny castellations on there. So it's like dropping a chip onto a board, right? And it's like I said, it's very small. So think of that as like a full CPU with the CPU size or smaller, but it's got everything you need on there. And it also, what's interesting is that the core compute module also adds Ethernet. So for industrial IoT capabilities and solutions, right? Ethernet's pretty important for that. So it's in terms of form factor and IO, like there's a ton of IO on those boards. You can control or integrate with just about anything that you can think of. I can't think of any piece of hardware out there, in fact, that you can't integrate. Even industrial sensors that run over like RS485 or DS12 or Modbus, like all of those are easily addable to these. So it's a very IO heavy, very hardware friendly design, both of these.
Mm-hmm. Okay. Well, let's talk about the .NET developer workflow and just some other things on your website, some keywords we haven't touched on. NetDuino. You've already talked about micro framework, but what exactly are you developing with on your computer? Are you in Visual Studio 2022 with .NET 6? Or are you using your specific class libraries versus ones from Microsoft? What exactly are we using when we, even to do the, maybe a Blink sample or just a really, really simple breadboard experiment?
Yeah. So we are fully .NET Standard 2.1, .NET Core 3.1 compliant / compatible. And we're working on upgrading to .NET 6. There's not actually a lot of change in there. It's in terms of the API surface, there's not much difference between those two. It's mostly the underpinnings, sort of the runtime stuff. But yeah, it's, we've got a Meadow CLI. So everything, all of the deployment and tooling is sort of based on a common core Meadow CLI command line, and then we build everything. And that's also available as a library. And then on top of that, we've built all these IDE integrations. So the experience as a .NET developer is actually no different than like if you were to file new a console app or a Xamarin app or a Windows app. You literally, you go and install the IDE extensions, and we're available on Visual Studio for Windows 2022, Visual Studio for Windows 2019, Visual Studio for Mac, and VS Code. We have full support for all of those. We don't have Visual Studio for Mac 2022 yet because they haven't released, it's still in beta and they haven't released their extensions framework yet, but you can use the 2019. So we have a real integrated experience that's just, file new, or you can even in the command line do .NET new Meadow, right? And have, so this the standard .NET Core SDK there. And everything that you would expect to have in an application is there. So you file new and you use, we use all of the same .NET standard APIs, and that means you can use any of the, most modern NuGets out there, target .NET Standard 2.2.1, and so you can use all of those, and you've got full debugging experience. There's step-by-step, line-by-line debugging on our devices in both Visual Studio, Windows, Mac, and VS Code. So it's very much like developing any other .NET app, and we have. When you do file new Meadow, and the IDE extensions have built-in templates for C#, VB.NET, and F#. So this really is a full .NET, experience. It's not a secondary experience. It's much like, it's built on the technology that Xamarin's built on, right? So
Okay.
it's a very similar experience, and you can add NuGet packages. You want to add a JSON package or something, you want to add whatever, like you want to add the SQLite.NET ORM that everyone uses to do mobile SQLite, right? Well, that's available. That's all available on Meadow as well. So,
nice.
You can use that NuGet package just as you would on a mobile or web app. So, you can do code sharing. And
all right, so I got some code, Control F5. I'm guessing I have to have it connected to my computer somehow. What does that look like?
Plug it in via USB. Think of this almost like a mobile app. Plug your device in.
All right, so I got it connected. And is the deployment to it when I'm ready to maybe, test it out, put it out in the field, do some tests? Is it a command line to build it, push it over there, or what does that look like?
Yeah. So when you're doing development, it's like you said, it's F5 or it's under. So say you hit the big button, right?
Mm-hmm.
And you select your device, you hit the big button, and your code goes and deploys, and then you've got full debugging and all that, just like you normally would. Now, if you want to go to production and you want to deploy those out to, so let's say that you build the next great IoT solution. Maybe you
just keep it simple. I got a chicken coop, bucket of water. I just want to test that there's water in there and it hadn't totally dried up, because that's right. Real. That's real for me, actually.
Yeah, no, it's funny. We were at Maker Faire a couple of years ago. And we actually had a smart chicken coop, and that was like the most popular. Like, we had people come up to us all the time. Oh, you have a smart chicken coop for sale? It's like, no, we're
totally
showing off the platform. But,
if the food runs out for a day, it's okay. But if the water runs out, especially in Texas, that's when you got dead chickens on your hand. Not fun.
Yeah. Then they get weird too.
All right, so walk us through. We got something we want to connect it to, and we need to actually get this out in the field. What are the steps there?
That's right. So, and this is something that we're actually working on right now, is the over-the-air update. So you do your device development. You've made a solution, and now you want to go out and put it in your chicken coop. You're no longer connected to USB. So you put your device into production mode, and that registers it with Meadow Cloud, and then that it's associated with your developer account and stuff. And then when you're ready, you can build your application and then upload it via the CLI to Meadow Cloud, and eventually we'll have a web interface for that. And what will happen is that we'll sign that application. It'll work a lot like the iOS App Store, right? So it'll get signed, it'll get encrypted. Your device will get a push message and say, "Oh, I've got an app update. I'm going to go download that." And it's going.
Wait a minute, my device that's out in the field. So it has to have Wi-Fi connectivity then?
Yeah, so Wi-Fi or Ethernet today, and we're actually working on a cellular module as well. So eventually, you'll just be able to run it off of the cell tower.
Okay, so if I'm cranking out a bunch of these, I'm guessing I do that step in the lab where they have Wi-Fi. If I'm pushing it out somewhere that doesn't even have Wi-Fi available, right? Yeah,
that's right. So you would when your device, you would put it into production mode, and then you would go deploy it, and then it would, like I said, either Wi-Fi, Ethernet, or soon cellular. And it would you would say, here's, Meadow CLI, publish new app. And what that would do is it sends it up to the cloud, encrypts, it actually signs as you put it up, just the way, like, think of it as like iOS, App Store deployment. Mm-hmm. And then the device gets a push message and says, "Oh, I've got an app update," and it downloads it with whatever, connection it has, and then unpacks it and puts it in place and restarts. And all of that, when it's in production mode, that device is, in a secure state. So though everything there on device is encrypted, we encrypt the flash, and we only allow apps to get installed that are matching your developer key and whatnot. It's very similar to, like, iOS in that or Android, like this typical mobile flow. So you can think of it honestly a lot like a mobile app. The analog is very similar. Yeah. So then it goes and deploys, and it restarts and starts up your application. And, hopefully it's bug free, but if it's not, if it starts crashing, it'll talk to the cloud and say, "Hey, I'm crashing. This is with my line of code that I'm crashing in." And you can, debug it, push another one.
So your quote, just enough operating system is enough to keep doing the crash reporting and swap out a different version of the app when it needs to.
Yeah, that's right. So that is, that's Meadow OS, and that's really where the value in our OS is through that management, right? Because there's, the OS provides a number of features like the SQLite. It provides the OTA updating and crash reporting, and also power and sleep APIs, which we're working on right now. So you'll be able to, the device can put itself to sleep and wake up in an hour and take a reading or something, or, wake up on input. So maybe there's a button that, gets, just some sensor gets actuated by chicken, and then that wakes the device, or it can wake up on LAN, on Ethernet or Wi-Fi, et cetera. So yeah, that's the OS. It's pretty cool. It's pretty sophisticated, but it's also very, very, very small, right? We don't have multiple apps. We don't have multiple users. We don't have, a lot of these frameworks that are running on a traditional desktop OS. So we able to make it super light, super fast.
Okay. So if we have a lot of these out there, giving each one an identifier is really up to the application developer, right? Or does each board have an identifier that you could just keep in a database?
Yeah, that's right. So each board, so you can name them, but each board has strong identity and naming via the certificate and key stuff, right? And that's all handled through the platform. In fact, one of the things that you can do is, like, let's say you want to sell this, you've made your smart chicken coop brain, and you want to sell this and you want to put this in the store. You would actually upload your app to Meadow Cloud, and then you would order, let's say you order 1,000 of these SOMs, these system on modules, there's our little core compute modules, and those would actually come with your application preloaded and with all the identity and stuff taken care of. So as they go out in the field and they get turned on, you could get a notification that these devices have come on, and you could push new app updates and this, like I said, strong identity and stuff, and all that's just handled for you.
Okay. So the core compute module, is it up to me to build the enclosure that it snaps into, or are there hat kits, or how does that work?
Yeah. So it's up to you to, build your product. We will have, with the core compute module, we have debug, what we call breakout boards, which are like the boards that it sits on top of. And we'll have some various options for that. So we'll have kind of we're working on this thing. It's called a hack board, and it's got a bunch of sensors on it, and it's got, like a light sensor and temperature and humidity.
It's kind of like a docking station for the core compute.
Exactly. So you can start with that. But ultimately, like if you're building a product, you need to spin the board that this would sit in and have your peripherals, right? So
at that point, I'm designing my own printed circuit board, and I reserve a space for the core compute module.
Yes, 100%. Yeah. And luckily that's gotten a lot easier, these days. And we've actually done a lot of work to make that, to demystify that. So we've got like a whole course on our website on like how to design a PCB to accept a Meadow. And like it turns out it's super easy, because the hard part was the Meadow itself, where we've done all of the high-speed signal routing and differential pairing and all the RF and all that crazy stuff, right? Like adding a sensor, adding some buttons and stuff, that's super easy, Anyone can do that.
Yeah, I imagine out in the field, some of those little small RF radios would be pretty popular, just to sling like a small data packet instead of relying on cellular or trying to get some Wi-Fi signal, right?
That's right. LoRaWAN, for example, is super popular. Or you can just use like the the RF chip that's in the Microsoft wireless keyboard, right? There's a lot of options for communications out there, and we've got drivers and we've got stories for those. So it makes it pretty easy to integrate.
Awesome. So last question, out of everybody who's actually deployed these in production, and they have their whole chain from development, testing, deployment, monitoring, upgrading, all that. What's the most common product mix? Do you see a lot of Azure pipelines, GitHub Actions? Do you see App Center? What are you seeing as the ones that seem to kind of fall into place and support this particular workflow well?
Yeah. So a couple of things. One, I want to caveat this with the fact that we are still in beta. So we expect to hit our production release sometime Q2, sometime early summer. And so we have a number of folks building production stuff on our platform today, but they're limited to going out to production until we go out to production. And for better or worse, they're waiting on us.
Sure.
But I would say that the most common thing that I know of folks building are climate monitoring stations. That seems to be like the entry point for a lot of folks. But we have people building air quality index sensors, CO2 sensors for like COVID in transmissibility in commercial buildings, and we have a lot of industrial solutions being built around like water treatment and industrial machinery and smart agriculture and logistics and tracking and GPS tracking, et cetera. And in terms of the, mix of products that we're integrating, a lot of folks integrate directly with their own APIs. So a lot of folks have their own APIs that they have either hosted in Azure, AWS or elsewhere. And because you have full .NET, you don't have to worry about like trying to squirt something through some weird, cloud restricted thing. You can just talk to a web API endpoint and use JSON to make and send responses and stuff. And then also, there's a little bit of an Azure IoT hub happening. That's something we just actually got support in place for Azure IoT hub. There was a bug in our network stack actually that prevented that from working. And then MQTT is a pretty common workflow. A lot of folks send messages through MQTT. And then, locally, SQLite seems to be super popular and important because you often are reading data. You're reading data and you're storing it locally, caching it, and then, you're squirting it up to the cloud, either some managed endpoint like, Open Weather API or like an Azure IoT hub endpoint node or something, So yeah, that's kind of the I would say popular solutions and stack pieces.
Gotcha. Okay. All right. So we're going to look forward to Q2 when this comes roaring out into the market. And yeah, I have in front of me the 2018 dev kit.
Yeah.
and I mean, it was a stick of gum from day one as far as form factor and smaller. So it's pretty exciting.
And the hardware, it's worth pointing out that what we have released in terms of hardware right now is already production ready. So it's really just the software stack that we're working on. And it's at this point, we're just polishing things up. And then we've got our last big feature that we've got to ship publicly is OTA, right? Over the air updates. And once we get that out and that's, stable, then we're V1.0. Nice.
Well, on behalf of every .NET developer out there, I just want to say thank you for making a board where C# is the first class development language, as opposed to just an afterthought, and you have to bang your head against the chip just trying to get it working, sort of. So that's great. I think you guys have this market cornered for now. So that's great.
Yeah, thanks. It's been a fun ride, and we're all .NET developers, so we get it. We want to do hardware, and we set out to make it easy. And I think we've been successful in that.
Perfect. Awesome. Well, thanks again for sharing the information on the show. Everything we talked about, we'll make sure to include in the show notes. And thank you very much.
Yeah, thanks for having me. Really enjoyed it.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.